We are looking at the exercise of section 3.4 and specifically question 156 on page 273. So in this question, we are given a position function for a hummingbird flying in a straight line, and we are asked to determine the velocity and acceleration of the bird at t=1 second, and also find the acceleration of the bird when the velocity is 0. So let's do this. I have already copied the question over to my page. So we have a little hummingbird, and it flies in a straight line, and the position function is given at 3t³ minus 7t. In part A, we are asked to find the velocity at time equal 1 second. So we know that velocity is the time derivative of the position function. So first, we have to take the derivative of 3t³ minus 7t. And using the rule that we established in the previous section, we get that this is 3 times 3t² minus 7, which is 9t² minus 7. So the velocity at 1 second is equal to 9. Plug 1 into this equation, we get 9 times 1 square minus 7, which is 9 minus 7, and that gives us 2, and the unit is meter per second. Because distance in this problem is measured in meter and time is in second. Alright, so that's part A. For part B, we asked to find the acceleration of the bird at t=1 second. Again, we know that acceleration is the time derivative of velocity. So this means that we have to take the time derivative ddt of the velocity function, and the velocity function we have figured out at 9t² minus 7. So I put 9t² minus 7 here. And again, using the power rule to take the derivative of this, and this will give us 18t, just 18t, because -7, when you take the derivative, that it becomes 0. Alright, so the acceleration at 1 second is equal to 18 times 1, which is 18, and the unit here is meter per second square. So then for part C, we are trying to find the acceleration of the bird when the velocity equal to 0. So in this case, we don't know the time yet, so we have to solve for the time when velocity equals 0. So we have to find t such that v of t equals 0. And we know that v of t is equal to 9t² minus 7. So we can plug that into the place where v of t is. So we get 9t² minus 7 is equal to 0. And now we have to solve for t. So add 7 both sides and divide both sides by 9. We get that t² is equal to 7 over 9. Now we have to take the square root on both sides of the equation. So we get that t is equal to square root of 7 over 3, or it could also be negative square root of 7 over 3. However, we can safely get rid of this negative solution, because in this context, it just doesn't make sense to have a negative time. It kind of go back in time, and it just doesn't make sense in this context. So we will ignore this negative solution. So at the time t equals square root of 7 over 3 seconds, so the unit here is second, the velocity is equal to 0. So now we're going to plug this time of square root of 7 over 3 into the acceleration function, which we already figured out that it's 18 times t. So acceleration at square root of 7 over 3 seconds is equal to 18 times square root of 7 over 3, and that gives us 6 root of 7, and the unit here is meter per second square. So the solution is that when the velocity equals 0, the acceleration is 6 times square root of 7.